if it is coming. Today you don't have the classes now, na? You are having time.
No, no.
Okay, then no problem. I have to go for the car servicing. That is why I'm asking.
Sir, I can
Just
do my until 30 I can do.
no. Up to 10 we will study. Then I will go. Little bit I will take time. Huh. That is I got the PDF is visible to you. PDF is visible to you.
No, sir, nothing is visible.
Nothing is visible. Okay, it is stuck somewhere. Hmm. See, I am sharing one PDF to you also. Okay, that you also have a look over it, and then until or unless you get the full confidence on the topic, kindly do not proceed. Okay, you let me know that is sir. Till now there is the problem. Dynamic. If still there is any some problem, some sort of problem you are facing, still you are having time to ask that problem daily basis. You can ask. Okay. I am ready to give as many hours you want. There is no problem for the timing from my side. I have full time for you. Okay. Just sharing the document. I think it is not. Now check, is it visible to you, Lechatlier Principle? Screen is visible to you?
Yes.
Okay. So see, this principle is there. What the principle is saying about, that is what is the Lechatlier Principle. This is what. Okay. And see, there in the chemistry, there are many type of reactions are there, like the ionic reaction are there. Suppose you are having NaCl, you are putting in water, it will 100% it will dissociate into what Na plus and plus Cl minus. It is 100%. There is no chances for to bring back. Okay, automatically it is not going to bring back. But some reaction are there, like the N2 plus 3H2. This is what the reaction, reversible reaction, 2NH3. 2NH3 along with that 92.8 some kilo calorie heat will release. Okay, that is negative. Now you see this reaction, what you will say? That this reaction is what is the reversible reaction? Yes or no?
Yes.
Reversible reaction means it is not going to ionize 100%. It is not going to ionize 100%. Now the second one you see CH3 COO minus and H plus. This one is also this is the what is the one is going RF and another is going to RB. This is going to combine to come back here, and this is dissociating to give this one. Similarly, if you see this is C6H5 COOH is there, what it is going to be, it is ionized like that also. C6H5COO minus, this is benzoic acid and H plus. If it is dissociate, so it will give this product. And if it is form, so this will give this product. Means both are possible. Forward reaction and this is the backward reaction. So in industry, NH3 is most important. Your, your father will also tell about this NH3. Why? Because this is the industrial base. This is what industrial base. Industrial base. Industrial base means corrosion-less base. It do not cause the corrosion. So in
Yes, sir.
the power plant, in spite of using NaOH, what we use NH3. Secondly, urea. Do you know urea? Have you heard about urea?
Urea, yes.
What is the urea? Urea is fertilizer. So this is also it is urea. This is ammonia is used in making what urea. And urea, how much quantity used in India, you cannot imagine. Okay. But the crop is growing nowadays. That is what the urea, based on the urea. Urea is extremely, what I mean to say, NH3 is extremely important, and this production of NH3 is reversible reaction. Getting? The much it is forming ammonia, it is dissociating also. Are you getting?
Hmm.
Yes or no?
Yes, sir.
Okay. Now, see this one. What is happening to this concept now? That if it is the going forward and backward, if
Can
N2,
you just wait 1 second, sir? I was writing.
okay, okay. See, if N2 and 3H2, it is combining to give 2NH3, and you need this product only. What you need? This product only. What you, this is available in environment, this is available in environment. You need the ammonia. But ammonia formation is two-way process. It is the rate of forward, rate of backward. As much as it is forming, it is also splitting into nitrogen and hydrogen. So how can you increase the production of ammonia? To study this production of ammonia, this principle is given. Which principle? Lechatlier principle.
Yes, sir.
Okay, now you got the idea about what we are going to study. And what the statement is saying, Sanoy, you see here.
The equilibrium
They
of a reaction externally, then it will be something so that it is adjusted internally.
Okay. So they are saying if an external stress is applied to a reacting system at equilibrium, the system which adjusts itself in such a way that the effect of the stress is nullified. This is statement. You can write the another statement also. What is the statement? When equilibrium, this is the when equilibrium is subjected to what, Sanay? When equilibrium is subjected to change in change in factor. What factor? Subjected to change in factor like temperature, concentration, pressure, etc. Then it will shift. It is going to shift. Obviously, it will going to shift. It will shift. How it will shift? It will shift in such a way that how? In such a way that it undo the effect. It undo the effect. What do you mean by this? Means the equilibrium will again restore. Getting?
Yes, sir.
If you are changing the equilibrium with the some factor, when equilibrium is subjected to change in a factor, temperature, concentration, pressure, then it will shift in such a way that it undo the effect. This is getting my point.
Yes, sir.
Okay. Means what? Suppose it is the N2 plus 3H2 is there. It is forming the 2NH3. So if you suppose you increase the concentration, this one, you increase it. So equilibrium will shift in such a way that that increased concentration will again decrease. Okay, it should again become the constant. That is, rate of RF should be equal to RB. Again, it should be at the end, it should be equal. Now, let us see this concept here. Ammonia is manufactured by Haber process. In this reaction, nitrogen and hydrogen 1:3 volume are made to react 773 Kelvin and 200 atm pressure. This is the reaction they are given. What they are saying? The point you see, effect of concentration. First point we are going to study, effect of concentration. So by the law of mass action, the increase in concentration of one reactant will shift the equilibrium towards the right. And here increase in concentration of hydrogen as more mole of it are used in preference to nitrogen has more effect. Means they are saying hydrogen is having more effect than the nitrogen. This is the competitive track problem. Now let us see. Let us see here. So I am writing N2 and I am writing that is H2. So it is giving what is 2NH3. Okay. Now this is the RF is there and RB. At this point of time, RF is equal to RB is there. RB. That is what is equal to this is Kc. This is what the equilibrium constant.
So what is
Equilibrium
the meaning
constant,
of
by the way, you cannot mention what is the equilibrium constant if you are mentioning. That is Kc will be how much? That is rate of forward equation rate by rate of backward. So this is the equilibrium condition. What is condition? Equilibrium. What
So
is the
what is the
equilibrium?
meaning? RF and
Huh.
RB, sir.
RB means rate of backward reaction, rate of forward reaction. Rate of backward means it is decomposing into this one, and rate of forward means it is formation. Is it okay?
Yes, sir.
Now, what you did in N2 plus 3H2, you increases the concentration. To which one concentration you increases? N2 concentration you increases. Add what you did? Add N2. You added the N2. Now, if you are adding the N2, the reactant side, there will be more concentration. Yes or no?
Yes.
So if the reactant side having more concentration, the reaction will go which direction? Forward direction. So that the increased concentration will be consumed. Increased concentration will be consumed. Yes or no?
Sir, add, yes, sir, add NH3 means more N2 will be consumed, so sir, it will be forward.
It will be forward. Okay. The one case you understood. So same is that is case one. This is case one. What you increase? N2. Case two. If you increase the hydrogen concentration, add H2, then what will be there?
Mm.
Man, you are not saying anything, yaar. You'll say loudly.
Sir, if we are adding H2, then also same will be occurring, forward reaction.
Then it is also same. Very good. Okay, good. What will be case 3? Case 3. Both.
H2
You added the
concentration,
both. N2 and H2. Then
sir, N2 and H2, N2 and H2 also forward only.
forward only. Good. Okay. Now, this is the case 3. Case 4. Case 4. What you did? You add NH3. You add NH3. Then
NH3 reaction backward reaction.
backward. Okay. Good. Backward. Then case 5. Case 5. Taken out NH3. Taken out NH3.
Taken out NH3. So then also forward reaction.
Then forward. Good. Very good. Case 6. Taken out. Taken out N2 or H2 or both. Then
N2 or H2 or both means backward reaction.
backward reaction. So now you understood the how equilibrium will shift when concentration is going to change. Yes or no? Is there any problem?
No, no, no.
No problem. So I am moving little bit. So effect of pressure. Now we are going to pressure. See, what is their P proportional to what is their number of mole? Yes or no? More mole, more pressure. Have you heard about this?
No, sir.
Pressure is what, Sanoji? Pressure is what? How the particle are striking on the wall of container. That is why the pressure generated. Yes or no?
Yes, sir.
So if suppose one vessel is having the only one particle and one vessel is having many particle, which will generate more pressure?
Sir, sir, more what will having more particle that will generate more pressure.
More pressure. Okay. So keep in mind. See, N2 and 3H2 equilibrium always we study in what form? We study in the closed vessels. We always study in the closed system, right? You apply the pressure. You apply here the pressure, right? So where the pressure will be more? This side, reactant side will be more pressure. More pressure. And here is less pressure. So when you apply pressure, pressure will be more in the reactant side. To nullify this effect, increase pressure, where the number of mole will go? Where the equilibrium will sit?
Sir, wherever there is more pressure, that side the other side the equilibrium will shift.
So it means forward or backward?
Sir, here more pressure is on the reactant side, so it will move forward.
Forward. This is the forward. See it. Above reaction indicate that formation of ammonia takes place with decrease in volume. Which factor is this? Huh. Hence, increase in pressure will favor the forward reaction. Optimum pressure for the maximum yield ammonia. So it is, you understood this one. What will
Yes.
happen if the decrease pressure? Decrease pressure.
The decreased pressure means where we are decreasing the pressure, the reaction will shift that side.
So the pressure will be decreased in the reactant side. So it will become backward. But increased pressure will be preferred here. Now, temperature, effect of temperature. See, what is there? This is the exothermic process. This is the exothermic process. Okay. N2 plus 3H2. It is giving 2NH3 plus it is liberating the heat. Okay. Now, what you did, this is closed container. In the container, you increases the heat. Okay. So, when you are giving heat to the system, already suppose it is the 92.8 kilocalorie is there. When temperature you given, when you gave the temperature, so suppose 100 kilocalorie you given in the form of heat. So the product side is having how much? 192.8 and reactant side will be remain only 100 kilojoule, yeah, kilocalorie, and this is kilocalorie. So where it is more in the exothermic reaction? Product side. So where the equilibrium will shift?
Sir, equilibrium will shift towards the reactant side.
Towards the reactant side means backward direction. So production of ammonia will increase or decrease?
Production of ammonia will decrease.
Okay, super. You read this statement and try to understand what the statement is saying.
So,
Can you?
reaction is exothermic, lowering the temperature in favor of the forward direction. Decrease in temperature results in a decrease in the rate of reaction. Its temperature is in the calorie maintained and iron is used as catalyst.
Hmm.
Understood, sir?
Understood. Thank you. Next one. What is the application of Lechatlier principle contact process? That we will cover a little bit late. Wait. Yeah. Hmm. Next one. We are going to study the effect of catalyst. Effect of catalyst. Can you tell me what will be the effect of catalyst?
Sir,
So
effect of catalyst. Sir, when we are increasing the catalyst, then it will increase in go reaction will go in the forward direction. Decreasing means backward.
catalyst increases both. What they are saying, both forward, forward and backward reaction equally. Backward reaction. This is they are saying equally. So that is so RF is equal to RB. So what we can that is not so you mentioned this is that is RF is equal to RB. Therefore, what they are saying, therefore, is there any effect? Therefore, no effect. No effect on what? No effect on equilibrium. You try to understand. You can have the note on it. Can you?
I have already written.
Understood or not? Have you? Is it okay? Is it okay? So I am erasing this one. Next one. Effect of addition of inert gas. Here we are studying. effect of addition of inert gas. Effect of addition of inert gas. What will be effect of addition of inert gas? There are two gases are there. Case 1, at constant volume. At constant volume. Constant volume. So if you are adding anything inert gas, like what inert gas can be? That is, it can be helium, neon, argon. They are non-reactive. So at constant volume, no effect on equilibrium. No effect on equilibrium. It is not having any effect. No effect on equilibrium. Now, case 2, at constant pressure. At constant pressure. So if the pressure is constant, at constant pressure, equilibrium shift. They are saying which direction? Equilibrium. Equilibrium shift in the direction of, more mole. Wherever the mole is more, in that direction, it will shift. Suppose if you are writing N2 plus 3H2, reversibly it is going to 2NH3. So if this reaction is taking place in two condition, what condition? Case 1, constant volume. Constant volume. And you are adding what is? Either you are adding the helium, or you are adding the neon, or you are adding the krypton, or you are adding the xenon. So if anyone you are adding in this one, constant volume is there, this is going to be no effect. No effect. Volume is constant, no effect. Case 2, constant P. Constant P is there, so it is going to be backward. Constant P, it is there. It is going to shift into the backward direction. Okay. This is the experimental case. Have you made the note of it?
Yes, sir.
Okay. I am giving you one of the note on it, that you also read that one. Otherwise, give me 1 minute.
Mm,
Huh. So you see the your WhatsApp number. WhatsApp na.
yes, sir.
I'm sharing you the PDF file. Then you read that one.
These Lechatlier principal problems.
No,
Yeah.
not that one. Not that one. Now again I'm sharing. There must not be
So,
any point of confusion here. Okay. See this. Have you get this one?
yes, sir. Got it.
Check back.
So in the addition of inert gas at constant volume, constant pressure,
Hmm.
equilibrium shift more number of moles.
Hmm.
So, okay, I understood this one. You told me this.
Which direction is shifting? That is the two cases are there, na?
Yes, sir.
Huh. So both the cases you understood.
Yeah, yes, sir.
I don't think you understood, Sanay.
Sir, you told me just now that here wherever we are adding the which was an inert gas, so sir, it creates constant stress in the equilibrium. So sir, to manage this stress, that wherever the number of moles are more, we weigh the reactant or product side. So that
Hmm.
side that will shift. So the equilibrium will shift. When it is
Hmm.
done in case of constant pressure, sir, but in case of constant volume, then nothing,
Hmm.
no effect is there.
Hmm. So both that is clear, na?
Yes, sir.
Okay. Now that is the one thing we study. Okay. Have you heard about the equilibrium quotient?
Mm,
Okay. Case 1 we study Lechatlier principle. Case 2, there is any other factors are there, concentration, pressure, effect of catalyst, temperature, this all we study. Case 2, based on Kc value, based on Kc value, we can determine what we can determine. We can determine direction of equilibrium. We can determine direction of equilibrium. So this is the case 2 type problem. You can determine direction of equilibrium with the help of the value of the equilibrium constant.
Sir, first you tell me the case one once again, sir.
Case 1 is Lechatlier principle itself. Case 1
Okay.
is the Lechatlier principle, na?
Yes, sir.
So what I am writing, it is visible to you?
Hmm.
Okay. So Kc value, if Kc value is more than 10 power 3, then it is going to be forward. And they are saying it is going to be mostly product. It will have the mostly product will be there. Kc, this is less than 10 power minus 3, backward. And if it is backward, this is they are saying mostly it is going to be reactant. Mostly reactants. Okay. That is reaction rarely started. Reaction rarely started. Rarely started. This is the point. Rarely started. And here is that is reaction about to complete. Reaction about to complete. About to complete. This is all the NCRT only. Nothing I am telling out for. If Kc is between, what is there? Between 10 power 3 to 10 power minus 3. Okay. Then both reactant and product. They are saying both reactants and product. Both reactant and products are in, what is the, are in considerable amount. Are in considerable amount. Are in considerable amount. Can you understand this? If the hmm, if the Kc value is coming 10 power more than 10 power 3, forward, less than 10 power minus 3, backward. If between 10 power 3 and 10 power minus 3, then both reactant product are in considerable amount. Is
Sir,
it
please.
okay? Okay.
Yes, sir.
Okay, good.
Sir, you keep this slide once again. Once, sir. Sir, I am ready.
Okay, check that.
Sir, there.
Okay, good. So moving na, I am erasing this one. Have you thoroughly read this NCRT book? No. No.
Sir, read 2-3 times.
This chapter also.
Yes, sir. Sir,
Okay,
exam
great.
was there before that I read, but sir, many I could not understand it very well.
That is the problem now. That is why teachers are required. See here, the some points are there, Sanoji. Here, the first point you see. Is it visible? NCRT book is visible to you?
Yes, sir. So NCERT book I have also.
If Kc value greater than what they are saying, 10 power 3, product predominant over the reactant, means product will be more than the reactant. If Kc is very large, the reaction proceed nearly to completion. For example, A. The reaction H2 and O2 at 500 Kelvin has very large equilibrium constant, 10 power how much? 47. So this is what is reaction is about to complete. Is it okay?
Yes, sir.
Next one you see, here is the value is there 10, 4 into 10 power 31. So it is also more than 10 power 3 now. More than, this is Kc value is what is more than 10 power 3, yes or no?
Kc value is more than 10 to the power 3. Yes.
Because here 31 is there, 10 power 31, too large. Millions of time more. Next one, this one. So this all reaction, this all three example are what telling? That is the mostly the reactant are there na forward direction. It means that it is forward direction.
Yes, sir. Forward direction, sir. That is whatever we are having this one that greater than 10 to the power 3 means forward direction. So it can be greater by as much number as it is possible.
Yes, 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 yes. Now you read the case 3. The
So
case
here it is larger
next
by a
point.
lot of degree factors. Sir, we have 10 power 3, but here it is 10 power 47. So definitely there will be forward reaction.
Okay. By the way, what is there? Kc is how we mentioning. That is concentration of product now. Concentration of product divided by what? Concentration of reactant. So when the value will
So
be
this
more,
way
when the
we
product will
can
be more, then the
define
value
this.
will come more.
So
Yes, or
how
no?
to find out for a particular reaction?
What? What are you saying? Repeat, please. Repeat your question.
Sir, how to find out Kc for a particular reaction?
Kc means what? Kc equilibrium constant you don't know. This one Kc.
So this will be given or what, sir? How to do in the problem? So that I'm asking.
Kc. For the different type of question, it may be given, it may be asked to calculate. What is the equilibrium constant? Equilibrium constant. Definition. Equilibrium constant. I think you did not study this chapter properly and then you jumped the topic. The the product of, how we are defining, the product of molar concentration of product of the ratio of, here is the point, the ratio of product of molar concentration of product raised to power coefficient, raised to power coefficient, raised to power coefficient
Concentration of
with
product.
with product of, with the product of concentration of reactant raised to power, raised to power stoichiometric coefficient. So what is there? Suppose A mole of A is there, B mole of B is there, reversibly it is going, C mole of C and D mole of D. So Kc, how you will write? You will write the product of molar concentration of product. So C and D are product, power C, power D. And product of molar concentration of reactant A and B. A power A, B power B. This is what the Kc. And by plugging the value, concentration will be given. Concentration will be given. So if the concentration are given, then you put the value this, then you will get the Kc value. Getting?
Hmm.
Okay. Can I erase this one? Say yes.
Yes, sir.
Hmm. Now come back here. Now you see, you read the Kc. If Kc value less than 10 power minus 3, reactant dominate over product, that is Kc is very small. The reaction proceed rarely. Reaction proceed rarely. You see the example here. What are the example? Here there is Kc value for formation of H2, 10 power minus 48, very less. So rarely happen. Here is the formation of NO, 10 power minus 31, very less. Now, this case, if Kc is in the range of 10 power 3, minus 3 to 10 power 3, appreciable concentration of both reactant and product are present. Consider the forming. So, H2 plus I2, it is giving Hi. Here, Kc value is what is 57. 57 is between what? This is 10 power minus 3 and 10 power 3. Yes, yeah, no. So that is both are present in the appreciable. Similarly, formation of N2O4 to NO2, conversion of N2O4 to NO2. This is what is the 4 in 0.64 into 10 power 3. It is also coming in this range, this range. So it will, both will be in the considerable amount. Can you understand this?
Yes, sir.
Now we are going for the next case, case 3. Case 3 for direction of equilibrium. Case 3 for direction of equilibrium. Direction of equilibrium. Direction of equilibrium. Direction of equilibrium. What is the case 3 for direction of equilibrium? If QC and KC, this there, and if QC more than KC, and if what is there, QC equal to KC. Okay, these three cases are there. QC is what? Equilibrium constant. You can say equilibrium quotient. Equilibrium quotient. Equilibrium quotient. Quotient. At any concentration. At any concentration. At any concentration. Equilibrium quotient QUO. QUO. Equilibrium quotient and at any concentration. Okay. And Kc, equilibrium constant. This is what equilibrium constant. When you are taking this one at equilibrium, at equilibrium, at equilibrium. So that is in this case of RB is equal to RF. This case. So two conditions are there. The both are defined. Definition are both are having the same definition. But what are there? QC is taken at any concentration. So it can vary anything. And KC is when the rate of forward and rate of backward are same. Okay. Now, if QC is less, if QC is less, it is less. So equilibrium will shift in what direction? QC is less and QC is more. So every reaction try to be, here concept is there, every reaction try to be at Kc. That is Kc, that is equilibrium. At equilibrium. Suppose if Kc is there, Kc is less is there. So what the Kc is do so that it become equal?
I did not understand, sir.
Huh?
Sir, every reaction try to be at Kc. What does this mean, sir?
Equilibrium. Here read the full statement. Equilibrium condition. Every reaction try to be in the equilibrium condition, that is Rf is equal to Rb. Equilibrium has to restore or not?
Yes, sir.
So if Kc is less, Kc is less. So concentration should be what? Concentration should become more. It try to reach to Kc. It try to reach to Kc. If QC is less means concentration is less. So it try to reach Kc. For that, which direction it is going to be?
Sir,
Forward.
which direction? Forward, yes, sir.
QC is more. QC is more. But it has to stay to the Kc. It has to stay up to Kc. So it has to decrease. It has to decrease. Means it has to decrease means equilibrium should QC is less, na? So
Ah, yes.
less means it go. Oh, no. A little bit. QC is less, na? So it try to match with the equilibrium. It try to match with the equilibrium. It try to match with the equilibrium means the backward. Means backward. It should be backward. Here is QC is more. So it will decrease. Equilibrium will decrease. That little bit it is confusing, yeah. Okay. You read the slide first. Otherwise it will create the problem. Here you see. Where you will find. See here the concept here downside is there. Two concepts are there here. The first diagram you see.
Sir,
What is
sir,
there?
just 1 second, sir. Here, one call is coming, sir. Let me give the phone to my mother, sir. One call is coming, sir.
Okay.
Just 1 second.
Okay. Hmm. You see less. Less है तो it is go to product.
Yes, sir.
Okay, see the diagram here. What the diagram is saying. QC is less there, na? QC is less than KC. So more and more. So here they are saying QC is less than KC. Net reaction grow from left to right. Net reaction goes left to right. This direction it has to go. That
Sir,
is
this
the
part
forward.
I've understood, sir. I've read the book also, this part. Sir,
Hmm.
what the problem is, sir, here, when I'm reading the book, then I won't be having much of problem here. Sir, where
Hmm.
I'm having problem is that, sir, you see, after this one, sir, this ionic equilibrium, acid base, sir, these places I am having a bit problem.
Hmm.
Conjugate acid, Bronsted theory of acid, sir, that one I'm having problems. So, sir, if
Hmm.
you clear those parts firstly, then that would be great, sir.
That will come now. This is the separate concept now. This is separate. Firstly, you understand this one.
Okay, okay.
Uh, this is the direction now. Equilibrium direction is there now. See,
Mhm.
QC is more than KC. The reaction goes from right to left. Means if anything, QC is more, so it has to decrease. If it is less, it has to increase. Because at the end, QC should be equal to KC. That is what the concept. So how it can be? If it is less, so it will go forward. And if it is more, so more means it is going to be backward. So that you need to understand. Net reaction grow from right to left. More is there means it has to decrease.
Yes,
Less
sir.
is there, it has to move from the left to right. Now go back to the here the what the we have taken. Okay, see this statement you try to understand what they are saying. Equilibrium quotient at any concentration. So if it is coming less now, if it is coming less, so QC is equal to what is there? Concentration of product upon reactant. This is there, yes or no? Kc is also
Yes.
there, concentration of product upon reactant is there. Okay, kindly make it clear right now only. Otherwise it will be. So if it is the less is there, if it is they are saying what? Less. If it is less, means product is less. That is product is less. Means product is less. That is why it is coming less now.
Yes.
QC is less means product is less. And here in this case, so what it should do so that it become equal to KC? What it should do so that it become to equal? Means more product should form. More
Mm.
product should form, na? So it should go which direction? It should go forward direction. Forward. Now come back to the slide here. Here you see. The next reaction left to right. What they have said? QC is less than KC. Net reaction goes from left to right. Can't you understand this?
Yes, sir.
Papa is there near?
No, sir.
No. I don't know you understood or not this one.
Sir, you can
Understood?
talk to him. No, sir. Phone number is with you. If you want to
No,
talk,
no,
you can
no,
talk.
no, 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 no. Yeah. I just want to know that if he is there, he can also explain to you. Sometime if it is getting confusion. Did you understand this case one?
Yes, sir. So this case I understood now because QC were getting product by reactor and KC also getting product by reactor. So in one case, if this one KC QC, I mean less than KC, so sir, that means product is more. So the product is more, product is less. Product less means sir, we need to increase the product. That means forward direction. Going about QC greater than KC means the R is less. R is less, reactant less. That means it should be backward direction to increase the amount of reactant. QC equal to KC will give the equilibrium.
Okay. Means all the cases you understand. This all means one you understood means another is the reverse of that one. Getting. Getting.
Getting.
Okay. Now let us solve some problem. Then only it can be clear. Okay. Too much time. Here the question. I am writing the question. Okay. 2HI gas is there. Okay. It is converting into H2 plus I2. This is the gas. And here is also gas. This is there. Kc they have given. How much they have? 1 into 10 power minus 4. Right? Hi concentration they have given. Hi. Then H2. Then I2. These concentrations are given. All the concentration. How much at I2 into 10 power? This is the minus 5. 1 into 10 power minus 5. 1 into 10 power minus 5. Okay. Predict the direction of equilibrium. Predict the direction of equilibrium. Direction of equilibrium. First of all, you should know the that one the problem. See, if A mole of A is there, B mole of B is there, C mole of C, C mole of C plus D mole of D. So if you are writing Kc, so it will be the same now. C power C, D power D, and the A power going to be A, B power going to be B. And Qc also writing. So it should be the same one. C power going to be C, D power going to be D, and A power going to be A, B power going to be B. But what is the problem here? It is at any concentration. At any concentration. It can be at any concentration. And when it will be when Rf is equal to Rb. This is the equilibrium condition. Equilibrium concentration. Equilibrium concentration. So now the case you have to apply. What are the case one? Case one. QC less than Kc going to be forward. Just now we study. QC more than Kc, that is backward, and QC equal to Kc, that is equilibrium. Equilibrium. Did you understand this one? Solve it. Solve it. QC, if I will write QC, here you see, you can write the H2, then it will be I2, then it will HI power, what will be there? 2.
So let
So
me
it,
I can do it.
okay, tell the answer. Okay. Have you understand this question? Question itself is important now.
Understood.
Hmm.
So we getting Q is equal to 1 by 4.
1 by 4. So 1 by 4 means you match with this one.
Greater.
QC is greater. So equilibrium will shift forward or backward?
Backward.
Backward. This is the backward. So now the first topic what you sent to me, that is, I think it is getting clear little bit. Yes or no? Say yes or no, yaar.
Yes.
Okay. Now the second topic you said the equilibrium concentration. Second topic you have sent to me equilibrium concentration, I think. Let me check. second topic is equilibrium concentration. So equilibrium concentration, what you did, that is the equilibrium concentration. This is how you have to calculate. So I am giving you the sum of the problem, and you solve that problem.
Yes, sir. I want to solve problem. Okay.
Okay, giving you. 1 second. Question is here. The rate constant for the backward reaction. Okay. RB is given. RB for hypothetical reaction is RB is how much? 1.1 into 10 power minus 2, and RF is 1.5 into 10 power minus 3. Then and not then, and KC is 7.33 into 10 power minus X. Then find the value of X. Find the value of X. Value of X. Dear Sanoy, here little bit changes there. There is no point at all. 733. Find the value of X. And okay, do it. How can you do?
Sir, KC equal to RB by RF.
Huh. RB by RF या RF by RB?
Sorry, sir. RF by RB. Forward by backward.
So what is the
That is
value of X they are asking? Tell me.
बोलिए घड़ियां निकालने के लिए थोड़ा सा निकाल दीजिए अभी ले जाना नहीं है साफ हो जाएगा क्या दिक्कत है यार अभी तो ले जाओगे ना गाड़ी निकाल
नीचे से वो नीचे से हो जाएगा
तो 1 मिनट अगर पहले निकाल दोगे तो गाड़ी क्या होगी बताओ ना अच्छा क्या होगा
आई एम लाइव यार
ये भगवान कितने देर में खाली
मैं निकाल दूंगा रुको ना How much is coming, Sanoy? Sanoy, wait now. Wait. You solve this. Okay, correct. So you are saying that the x value is -2.
No, sir. Sir, I
Ah.
have a problem. Sir,
Hmm.
sir, you have given KC.
Ah.
Uh,
Ah.
sir, KC you have given this one. Sir,
Hmm.
but RB value is 1.1 10 power 2 you have given, but sir, you are telling KC equal to RF by RB.
Hmm.
So, sir,
No, no,
KC
no.
equal to RF by RB.
Ah.
So, sir, if you have given RF value and RB value is interchanged, then the answer is coming. Sir, otherwise this is not coming. Sir, you check because this value 733 not coming. Then, sir, formula will be RB by RF. If we have to continue with this value.
Here they are saying 1 by 1, you are putting 1.5, 10 power -2, 10 power -3. This is too much echo is coming here. Where is? Wait. Why the echo is coming here? Maybe they... Huh. So if you are solving, it is not coming 733.
Sir, just now you told na reaction constant Kc value is F by Rb. But sir, what you are doing here is Rb by Rf. Sir, you check the value once.
The rate constant of forward reaction and backward reaction is 1.1. This is there.
So 750 will come, sir, if you do 1.1 by 1.5. Sir, that is how I have done when you see, sir, I have made a box. Sir, if Rf equal to 1.1 and Rb equal to 1.5, we are getting the value. Sir, but in the given value, what we have given, that answer is not coming.
Oh my God. Wait here. Actually, I don't know from where the sound echo is coming.
So no echo in my side.
My side it is there too much echo. No, my itself is getting to be. Now, see again.
So I have no problem with that, sir.
Wait. Somewhere. It's on, I think. Actually, what is the problem? Somewhere the another device is on. Yes, right. Oh. Here is the Sanoy, it is coming here. How you are saying?
Sir, 1.5 by 1.1 cannot come to 733.
They say this power is also there now.
Let that be, sir. But 15 by 11 is not 0.73.
15 by 11, how much? Acha, this is RF. This is RF.
So that is what I was telling. No, the value is a bit different. So that way I have done. That is correct answer only coming.
Arey yaar, I by mistake I place here. Here is the weight.
So then this one is correct. This one is correct. This one is correct. RF by RB value is coming.
Actually, the problem is whatever I am saying that is coming twice to me. Is it coming twice to you also?
No.
Audible?
Yes.
I am giving you one more question. You solve it. Here they are saying that is PCl5, PCl3 and Cl2. These are all concentration given. 0.8 into 10 power minus 3, 1.2 into 10 power minus 3, 1.2 into 10 power minus 3. This is there. Find Kc. They are saying find Kc for PCl5 reversible, PCl3 plus Cl2. Can you do?
Then
Sound is not good.
one 1.8 into 10 power minus 3.
Hello, Sanoy, not audible.
No, sir, not audible.
How much is coming value?
1.8 into 10 power.
1.8 into 10 power, how much it is? Minus 3.
Sir, can you please
Why
disconnect
the
and join
sound
again?
is not
My
coming?
voice is
Let me check
coming.
with the mic. Now coming sound?
Yes.
Okay. Now giving you one more question. Let us solve another one.
Is correct or not? 1.8 into 10 power minus
Correct,
3.
correct. Okay. Okay. What is there is Sanoy, one two concept you try to learn also together. if the reaction is double, suppose here is the A mole of A is there, B mole of B is there, it is converting into C mole of C. So this is the Kc. We mentioned Kc. Now C is converting C mole of C, it is reversing. C mole of C is reversing to give what is reversible reaction A mole of E, B mole of B. So that is Kc dash is equal to 1 upon Kc. Okay.
This one I know. This one I know, sir. This one was told in school, I remember.
Okay. Suppose if suppose here is the, if you multiply this reaction, suppose 2C mole, it is coming converting into 2A plus 2B. Then what will be there? Kc dash is equal to 1 by C square.
Sir, why? 1 by K should come, no?
We multiply, na? Multiply by 2, na? Here it is 1, 1. Suppose it is 1, 1. All are 1, 1. These all are the one value. So what will happen? After reversing U square, so this will be 1 by Kc square. Can't you understand? If suppose C by 1 by 2 is there, it is converting into 1 by 2A plus 1 by 2B. So Kc dash is equal to 1 by Kc power 1 by 2. Whatever there is the forward, that will come power. Is it? For the reverse reaction. So this will be the answer. Now, what will be happening? One more. There are 4 cases are there. One more case study. So A plus B giving C. Okay, C. So this we are writing Kc. So C 1 by 2 A plus 1 by 2 B giving 1 by 2 C. Then what will be the Kc dash? What will be Kc? Kc power 1 by 2. That is the root Kc. Yes or no? All the cases understood? You just simply saying, I don't know you are understanding or not.
So you give me the question from this one, then you will know if I have understood.
2AB, it is going to give A2 plus B2. The Kc is 49. Then find equilibrium constant. Find equilibrium constant. Equilibrium constant for what they are saying? AB giving 1 by 2A plus 1 by 2B. Okay. Solve it.
HDFC Bank.
Solve it.
So this one is a different from what you gave, sir. What you gave, all the coefficients were same. Here one is 2, others are 1.
This is not there. This one.
So this is also A, B, C, all are 1 only, no? On the top one. This one A, B, C, all are 1. So here A, B, C, all are half. So here only A and A, B is 1, but A and B are half.
So what? 2AB giving what? A2 plus B2. For this one, we are writing Kc. Right? You divide AB, 2AB by 2. 2AB by 2. And they are saying not AB by 2. Here, no need to divide here. If you are dividing this one, what has happened? This 2 cancel out. So it become what? AB. And you divided this what is there? A2 by it will be 2 and B2 by it is 2. Not A2. Let me check the question. A2, B2. This is not a problem. These 2 and nothing has to do. They are not the coefficient. They are not the coefficient. So nothing is going to be problem. Can you see this one?
Hmm.
Huh. So this equation will come if you divide, if you making half of this one, if you are making half this one, if you are making 1 by 2, so this 2 cancel out, so it become a 1 by 2, 2 cancel out, it become
So, sir, how
otherwise
these two cancel?
this will not be cancelled. This will not be cancelled.
This will not be cancelled.
But this become let it be like that. In the book, I think it mistake they have done. A2 plus half B2. Now is it okay?
So, not audible.
It will be audible.
Now.
Now solve it.
Sir, what you changed the question, sir? Which part you changed?
I did not change. Here is the I put the A2 and here is B2. And rest of things are same. See
Sir,
this
let it
case. Let it make this concept clear. Initially A plus B giving C. This is the KC. So you divide everything by half. So equilibrium constant, new equilibrium constant become what? The coefficient goes to power 1 by 2. So 1 by 2, power 1 by 2 means root of Kc. So Kc dash become Kc, root of Kc.
Sir, here I want to say one thing. Sir, here you see, sir, if you see this one,
Right here, right here, right here.
sir, here I want to show this one, sir, this half, and this half. Sir, that means, sir, what I am saying is that the coefficient you have for A equal to coefficient of A equal to coefficient of B equal to the coefficient of C. So, sir, but sir, what in the question we are having, that is we are having coefficient of A is we are having 2. So, sir, B and C we are having 1. So, sir, if we divide by half, we will get coefficient of A as 1, B and C will be half. So, sir, this one is different from this case.
No, same. Here you see, you divide this one, divide by 2. 2AB you divide by 2, you divide by 2, you divide by 2. So exactly this equation will come now. 2 will be cancelled out.
This
So
will
this question is reverse. This question is divided by 2. This equilibrium, this reaction is divided by 2. So new equilibrium constant will be what is the divided by 2 means the coefficient will go power mein what will be there, power 1 by 2. Simple. So power 1 by 2, this is 49 given, this will be root of 49, that is 7 will come.
So that means, sir, whatever you are dividing with, that will go as a power.
That is, if you divide, the Kc will become, Kc dash will become Kc power 2 divide by 2, na?
Yes.
Divide by 3. If you divide by 3. So what will be there? Kc dash will be Kc 1 by 3. This is multiply. If you multiply, so if you are multiply by 2, so Kc dash will be Kc, what will be there? Kc, you multiply na, Kc square will be there. Whatever the coefficient is there. If you reverse, if you are reversing, so reversing Kc dash is equal to 1 by Kc. Reverse and square. So Kc dash will be 1 by Kc square. Reverse and divide. Reverse and divide. So what will be there? Reverse and divide. Kc dash is equal to 1 by Kc power 1 by 2.
So keep this slide for 1 minute and write.
Done.
1 by k.
Hmm.
Reverse.
Can I?
So you can divide.
Hmm.
Done.
Okay. Write down the another question. See there. Kc or N2 plus O2 giving 2NO is how much there? 7.5 into 10 power minus 9. Then find your brother is enjoying like anything. You say to him that you just enter in 11th, 12th, then 9th, 10th, then he will his enjoyment will be vanished. Now calculate this one. Find the equilibrium constant. Now let us see what you understood.
2NO N2 plus O2, yes. 2NO N2 plus O2, that means reversing. Reversing, therefore, Kc dash equal to 1 by Kc, 1 by 7.5 into 10 power 9. That means
Hmm. Tell me the answer.
tell it. Point 13 into 10 power minus 9.
So scientific figure you tell na. 1.3 into 10 power 8.
10 power minus 8. 10 power minus 8.
Minus 8 or 8 only?
Sir, minus 8. No, reversing. Oh, sir, you have given here minus 9.
So reversing means it will go in the numerator, so it will become plus 9. So 1.3 into 10 power 8. Yes or no?
Sir, you give some
So
more question based on this ones.
now, Sanoy, I was supposed to go a car servicing I have to do.
You go then.
Okay.
You go then.
Otherwise, if I will get late. Next one gives energy and equilibrium are in yes. And next class we'll see. This we will try to finish that one. Okay.
Okay.
Okay. Bye.
Thanks.